Finally, the last filter you'll implement is called blur. In blur, your task is going to be to take an image and create a blurred version of the same image, where everything is a little bit softer. Let's zoom into this image a little bit to see what this actually looks like. Notice that if this is the original image, this is what the blurred image looks like. Notice that the details are a little bit softer, and it's a bit tougher to make out. So what does that algorithm actually look like? How do we take an image and blur it, so to speak? Well, let's look at this image, a simple 6x6 image where we have red and blue. And what would it look like if we were to blur the image? Well, the blurred image might look a little something like this, where the details are a bit softer, and you can't quite make out the lines as crisply or as sharply as you could before. You can look at them side by side here. On the left is the original image, and on the right is the blurred version of the same image. You'll notice that the pixels have changed their color values slightly. The pixels that were originally just pure red now look a little more blue, and the pixels that were originally blue now look a little more red. So how do we actually do this? Well, the type of blur we're going to do is what's called a box blur. And to implement a box blur, we're going to compute the new value for a pixel by taking the average of the old color values of all of the 9 pixels that form a grid around that original pixel. In other words, all of the pixels that are within one row and one column of the original pixel. What does that mean for an image like this? Well, if we take this pixel, for example, and we want to compute its new color value in the blurred image, we're going to do that by looking at the original color values of these 9 pixels, the pixels that are within one row and one column of that pixel. Likewise, to determine the blurred version of this pixel, we're going to take the average of the original color values of these 9 pixels. Of course, not every pixel in our image has 9 pixels that form a 3x3 grid around it. Let's consider an edge case, for example, like this pixel. What happens now? Well, instead of averaging 9 pixels to get the new color value for this pixel, we're instead going to average these 6 color values, because these 6 pixels are the only ones within one row and one column of that original pixel. And likewise, if we look at this pixel down in the corner, we're going to compute its new value by taking the average of these 4 pixels, the only pixels that are within one row and one column of this particular pixel. So let's take a look at an example in a little more detail by calculating the new value for this pixel if we were to try and blur this image. In order to do so, we need to look not just at this pixel, but at all of the pixels within one row and one column of it, which will be this grid of 9 pixels. Let's take a look at them in more detail. Notice that the blue pixels have a blue value of 255 and a red and green value of 0. And the red pixels, of which there are 5 of them, have a red value of 255 and a green and blue value of 0. So what are we going to do to filter the pixel in the middle here? Well, what we're going to do is calculate the average amount of red, the average amount of green, and the average amount of blue. The average amount of red across all 9 of these pixels is 142. 5 of the pixels have the maximum amount of red, and 4 of them have no red. As for green, none of these pixels have any green at all, so the average amount of green is 0. And the average amount of blue is 113. Again, all of these rounded to the nearest integer. So what that means is that the blurred version for this new middle pixel is going to be based on the average of the original color values for all 9 of these pixels, which means it's going to now have a red value of 142, a green value of 0, and a blue value of 113. If we do that same process for each of the pixels in the original image, determining the new color values for each of red, green, and blue by taking the average of the original color values for all of the pixels that are within one row and one column of that pixel, the end result is an image that looks like this, a blurred version of that original image. And once you've done that for every pixel in the image, you can test this by running /filter, passing in -b to specify that you want to run the blur filter, then specifying the input file that you'd like to use as a source, and of course the output file. Once you've done that, you should be able to take the original image and create a blurred version of the same thing. My name is Brian, and this was Blur.